All right. Should be going by now. Yeah, I can easily hide everything here. Okay. Yeah, I think I fixed everything that was wrong. Well, I had some minor issues with sound, but now everything should be good. Whew. Yeah, sorry for running a bit late. High vis, I can see. Oh, we already started. Okay. So, is it fine? Yeah, I think everything's fine. It's just my second laptop having issues with showing me the chat. Just several seconds I will refresh everything, and what do you mean we don't have connection here? Yeah, so just to give you like a quick introduction while I'm solving some complications. So I solved like almost every problem on binarysearch.com. I only have like, I don't know, 4 to go. And these are like the hardest ones. So if we click to unsolved, then I only have 4 harder questions, which are actually like very old, from the times of first weekly contests. The room is private, but you can find the link down the description of this video. So yeah, maybe we actually should make it public. Let me fix this because oh, actually maybe no, I have it. Okay, failed to leave room. Okay, so I made it public. I believe you can now see it from the main menu, or whatever that is, whatever you call it, from the lobby. Yeah, from the lobby. So yeah, we have like final 4 live. You can join. Because there is some activity going on here. I'm not sure what this is all about, but yeah. So finally we can get to solving problems. I think everything is running fine. Yeah, hi Immortal. We have 4 quite hard questions. I'm not gonna lie, I already like encountered them several times because, you know, when binarysearch.com makes these rooms out of random questions, and obviously if you solve 1000 problems and you encounter pretty much every of them, like, but it's just I didn't have enough time to solve them, so maybe I already have some idea about them, but it won't be like instant solutions. Okay, so this I believe is from like very first or like second or third weekly contest, so more than a year ago. We are given 3 integer lists of same lengths, deadlines, credits, and durations, representing course assignments. So we have like some jobs, they have deadline, they give us some profit, and they take some time to I don't know, to do these jobs, I guess. So to get profit, you obviously need to finish before the deadline. Yeah. It's what we already figured out from the variable names. If you start an assignment, you can work on an assignment on the day it's due. Okay, so it's like deadline should be greater or equal to the finish time. We are currently on the start of the day 0, so we can use the day 0 for some useful activities as well. We want to find the maximum credit or profit or whatever you call it from some subset of assignments. So the first idea that comes to mind is that like what is the maximum profit from solving any subset of questions? I think I should actually make it a bit bigger, like this, I guess. So max credit, I believe they call it, from every subset of assignments. But of course it's too much, because like if you have n assignments, then there are a total of 2 to the power of n subsets. And probably we also like want to have like for every possible day, we want to know what is the maximum credit from every subset of assignments and every intermediate day. But that's of course too much. That's big O of 2 to the power of n times max d. Now max d is not a problem because it's bounded by 200, so max d is at most 200. That's actually nice. What is not nice is that we, like in a straightforward approach, we can have any subset, and there are just too many subsets. So probably we actually care, like we want to find some optimal substructure in this problem, which will guarantee that we don't have to consider all subsets. Now, usually such things are done if you can say like for every prefix of assignments. Oh, we don't have auto-completion here, I'm sorry. For every prefix of assignments and every intermediate day, right? What is the max credits? But here, like such, sometimes it works, sometimes it doesn't. And I believe that here it doesn't, because you don't necessarily want to complete jobs or assignments in the order, in the input order. Yeah, I think it's sort and DP. Immortal is right. So basically our idea here is to sort assignments according to some total ordering that will result in us having, like, being able to consider only prefixes. And how should we sort? Like, consider any optimal schedule. Okay, so any optimal schedule. It looks like this. So we like started I don't know, some job, second job, then ended second job. I should really write it like this. So we started second job, ended second job, I don't know, started first job, ended first job, started, I don't know, first job and ended first job, and then we ran out of time. So obviously jobs are not intersecting, and we want to sort them. Basically, we want to say that for every optimal schedule, there is a schedule that follows some reasonable ordering. Actually, moving chat to binarysearch.com, let me make a minor adjustments, and we will be able to do that if I make it like this. It should be fine, because now like people will actually see the binary search chat. Because before that, like my camera was covering that on stream, I believe. So yeah, so we want to process assignments in some sorted order. What is like? Imagine how do you solve assignments in real life? So we have like a deadline for, I don't know, math on May 20th, and we have deadline for computer science on May 30th, right? So probably we will solve math first, and then we will solve computer science assignment. With the general idea being that we, like, if deadline is later, then we probably want to solve that assignment later, right? Because it doesn't really make, do on the last day, immortal is totally right. Yeah. And like this is actually, this is the way to solve this problem. So we want to sort our schedule in the deadline order. So like whatever has the latest deadline comes last. Because like if imagine that this event, this assignment is actually the one with the latest deadline. Why would you do it before something else that probably has a smaller deadline? So if you change them around like this is still fine, right? Because it had the last deadline, which was greater than deadline of this problem. So actually deadline 1 is somewhere here. And here potentially like it was actually smaller or equal to deadline 4, because we could do assignment 4 here. So and deadline 1 is greater than deadline 4, so this schedule is also fine. And this assignment we solved it earlier, so obviously no problems also. So like this we can basically bubble sort assignments that we do. So that in the optimal schedule, in any optimal schedule, we can sort the assignments we do in the increasing order of deadline. If we do it, then we can actually solve for every prefix of assignments and every intermediate day, which will be big O of n times max d, which is completely fine dp. Although I believe that it can be something like, no, it is just this, I believe, because we only have 2 transitions per state, which are to solve the assignment and not to solve the assignment. We don't have much choice here. But yeah, let's write some code. Let's actually leave it. It doesn't do any harm. So assignments. I believe we would like to zip everything together to have like full assignments, all information about assignment in the same place. Then we can sort assignments. Our key will be what? We want to sort by deadline. Oh, actually deadlines come first, so we don't even have to sort anything. And then yeah, let's call it A for short. And we have that many assignments. DP, max profits. Max credit, max credits, okay. D will be max deadlines. I don't know, let's just call it just 100. Wow. Oh, that's an old habit of like pressing Ctrl S all the time. Okay, what do we want to return? maximum credit. So here we'll have for I in range n, I believe. Potentially n plus 1 for empty prefix. Here we'll have initial maximum credit is 0 for D, for J in range D plus 1. Now here I believe we can return just -1, -1. So for the entire prefix for the entire array, right? And for the last deadline, even if it's like 200 or maybe we actually should change it to max deadlines. Okay. So here we have to check so J is a star day, okay? Day of ice assignment. So therefore, if what? If J plus duration is a of ice assignment, if it is less than or equal to deadline of this sync, then max profit Yeah, to be honest, I don't know what raisin gun means. Maybe I'm just illiterate and everybody knows it, but I don't. So max profit here equals maximum value of this, and then maximum profit at J plus profit from that particular task. Probably we don't, like if we do only, we make only one transition here, which means that we don't consider the case when we don't do the job. Because it stays considered like in the previous values of maximum profit. So what I believe we should do is we should just take maximum of everything in maximum credits. Let's run on the sample test case, probably max credits. Yeah, I no, it's funny because like it clearly shows that I'm not interested in maximum credit. I'm only interested in maximum profit. Okay. Maximum credit. Yeah, I definitely forgot this thing. It's I plus 1, I believe. And here it should be ice day, and here it should be ice task. No, here it should be I plus 1. Right. Yeah, we got accepted for, no, we got accepted for example 1, which means nothing, but let's try. Very cool test case. No, like, we should just return, okay, we will just return here. Interesting. Because we don't have to do anything, probably we want to add +1 here, I'm not sure. Yeah, okay, whatever. Oh, still wrong. Okay. Oh. Because we can work on day 0, so I believe we should do it like this. Or we should just, I believe, increment every duration or every deadline by 1. Because it means like we can finish on that day, right? No? But yes, yeah, then we will get out of range, so. Yeah. No? Okay. Fascinating. I believe it has something to do with like we can work on the last day, and also we kind of like start on the first day. Okay, we'll just print maximum credits. It's like the first day. It looks like we can, like, we should just increment every deadline by 1. I don't know. No, it still doesn't work, but why? Yeah, let's take a closer look. Like, max credit first argument is number of jobs. So with no, but let's think. Like deadlines actually become 4 and 8. 4 and 8, right? Four and 8, and they have credits of 51 and 50. Oh, okay. Yeah, and how do we deal with that? We are currently at day 0, we add 4, it's at most 4. Makes sense. Oh, I actually no, but when J is the first day that we can work on, right? So J becomes J plus duration. Absolutely reasonable. If it J plus duration is the first day when we can work, and also deadline is after we added 1, it's the same thing, basically. So here it says that if we complete 0 jobs, then our maximum credit is 0, reasonable. If we complete first job, then our maximum profit is 51, and it's on day 4. Okay. Then if we complete first 2 jobs, then our maximum profit is 100 on day 5, actually, for some reason. Why would that happen? No, I mean, like, why don't we have... Actually, how did that happen? $51. No, 51 is correct. The problem is that we don't take that 51 to this 50. Oh, because we just have to copy, right? Okay, yeah, I guess it makes sense. Yeah, we can, yeah, we should have done something. I mean, we should have considered the transition when we do nothing. Yes, yes. So yeah, just copy. Yeah, that also was the thing. Immortal says that we can do the task on the last day, but I actually already addressed it by incrementing deadlines. My problem was that I haven't copied that straight away, so like I did not consider the case when we don't do the job. I only considers like how can we extend the current version, which is clearly not necessarily extendable. Let's put it this way. So we can clean this up a bit. Probably you can do it like better with, I don't know, just cache it, like last recently used cache, and you're fine. And probably now, because of that, we also, like, because we considered whatever is, like, don't do the job, I think I can also do this, no? No, because we like only consider what is the last day, so probably we should return this. Yeah, something like this. I don't really know. Maybe you can go even faster, but that's not the point of this. Should we have several editorials? Yeah, that's top down. That's actually not n squared. Because like current time can take any value. Oh, I typed something wrong. Mass calligraphic. Yeah, at least this is correct. Good job. 01 knapsack. Is a reduced assignment or redundant? Well, yes, but we also have like this, so yeah, no. No, this is a good way to phrase it. Set. Okay, whatever. N times D, n times max D is better thing, but yeah, it's still the same. Also, it's top down, I believe. Yeah, so for some reason everybody's doing it top down. I didn't really know why. I find. No, maybe you're right, and it's like easier not to sync. But like, Bottom up is not particularly difficult, right? Yeah, so we solved one problem, which is really good for us. Actually, Immortal solved it even faster. All the credit goes to him. And we have that problem, which I believe strings down under is just a bit overcomplicated DP again. But before we go here, I also wanted to say several things here. So I actually know from one of my computer science classes this problem is NP hard. And what makes it possible in our case is that deadlines are small. You may say, wait a minute, we solved this problem in O times of n times max d, right? So how can it be? Yeah, let's explain. So maximum credit, let's explain the solution and also why it is actually not polynomial. No, I've seen it. It's just that we have some delay. I have both YouTube chat and binary-search.com chat open. So max credit at task and day, max credits from some subset of first. Let's call it I and j. I tasks during our first j days. And then you have two options, like don't do the current task. Right, then you just copy the results from the previous row, and here you have option to do the current task and spend some time. Probably it's better if I write it like this, so no, I don't really know. We can clean this up actually. Yeah, I'm just cleaning some things up. I believe it will be much more readable then. And also we'll avoid some potential mistakes here with code duplication. Like whenever you have some complicated expression, you can just put it in a variable and you decrease the risk of mistakes. Plus credit. No, I forgot to change something. Name j is not defined, okay. Name j should be start. Yeah, like that's actually, I don't know, there is no like reason why it's faster, but it is faster. Okay, so something like this. Task assignments. I should call them consistently. Oh, again, so I try to save it here. Okay, I believe that like this should be our editorial style submission. Yeah, so we do the following. Like, first of all, because we can work on the deadline day, we just increment every day by one, not to think about it. Then we bash everything into assignments, so into one variable. That's much more convenient. Then we sort our assignments. They automatically get sorted based on the deadline day in the increasing order. Then we say like some basic check. If there are no assignments, then we can't make any profit. I think what is the... I actually don't know. I think... Yeah, we can do it like this. So now we'll do dynamic programming. We want to find maximum credit that we can get from some subset of first I assignments during first j days. So we initialize with zeros, obviously. Then we loop over assignments. We can also add it here. I don't know which one is faster. No, probably yes, previous was faster, but whatever. Like, we can skip the current assignment. I keep calling them tasks, I don't know. Okay, so if we don't do the current assignment, then our credit stays the same, so we just copy one row of our DP. Otherwise, we loop over all possible start days. We consider what is our end day. So we think what happens if we start doing that assignment on that start day. Well, we will end it on day start plus duration. So it will be like the first end is actually the first day that we can work after solving this assignment. If it is less than or equal to deadline, so it's valid. It is valid for us to do that assignment now. And we say like, okay, maximum credit on the beginning of day end, we update it with whatever is the maximum value, which of like its current value and maximum credit from previous I tasks and start. And also like we add the credits that we earned from that assignment. And we return whatever is the maximum credit that we can get after solving all assignments. So that's what we did. The complexity of this solution is of n times maximum value of d. Don't get tricked. This is actually exponential. Because like this max d is not a perfectly valid way to write complexity. Because usually we think of complexity like something of big O of f of n, when we say like n is input, right? But that's wrong. That's wrong. One like particular example that I really like that shows why this wrong is RSA crypto system. So it basically it was and it is a very famous crypto system which works as follows. The basic principle is it is hard to factor huge integers. But you may say like, wait a second, we know a perfectly fine algorithm that works in square root of n time, right? You can just say like, okay, every number is either prime or has a divisor which is at most square root of n, so we just check all of them and voila, we found a divisor, so we factored n. So from one side we see that it's hard to factor huge integers. From other point of view, like it seems like we have like a polynomial time algorithm for factoring. Now, of course, the trick here is that Shor's algo is quantum algorithm, And like we are talking about complexity in, I don't know, random access model on standard non-quantum computer here. So this looks polynomial. So we have a logical contradiction here. Like it's hard to factor huge integers, but we have a polynomial time algorithm for factoring. Now, of course, trick here is that n is not input. N is input size. So if you think about it carefully, it's how many bits do you need to write n in binary system. So with n bits, you can actually write numbers that are up to 2 to the power of n. And when you take square root of this, it becomes like, okay, it's 2 to the power of n over 2. So it's basically the same. Like you only got a tiny fraction faster. No, like you went much faster, but if n is 100, then you're still doomed. No, like 100 is not enough, probably 160. Something like this. And the same thing applies here. So if n is input size, then actually to write integer d, you only need, you don't need that many numbers, that many digits, that many binary digits. So if max d, let's say, is k digits long in binary, and maximum d can be up to 2 to the power of k. And that's why like our solution is exponential. And in general, this problem is NP-hard. So we are very lucky that deadlines are at most 200. And that's a part of my approach to problems. Like in our problem, if it is hard in general, then you must be missing some of the constraints. Because like everything they write here, you need to leverage it in some way, or you won't get optimal complexity. Usually it is. So we really use the fact that deadlines are very small, because it means that like if we consider, I don't know, 8 tasks, they have 256 possible subsets of tasks, but all these subsets can't all take different times to solve. So basically, we will have some 2 subsets which take the same time in total. And that's why the number of states in our DP significantly decreases. So that is just one thing that I was thinking about during solving this problem, because I know that in general this problem is NP-hard. So if you don't want deadlines, then it's NP-hard. You can construct a reduction to some well-known NP-hard problem. Actually, I believe NP-complete is the right way to say it. Okay, but anyways, we spent too much time on that problem. We wanted to solve everything in 90 minutes, and we spent 45 minutes discussing that problem already. Okay, strings down order. Do you want me to solve this, or do you want me to solve... I actually want to solve question 3 first, because I know that it's not all that complicated. Yeah, I think I will solve Q3 first, and then I will come back to Q2 probably. So in Q3 we have n items that are numbered 0, 1, and minus 1. We get a 2-dimensional list of size S called sets. So what it means, we can buy the I set for some price, and we'll receive every item between sets I from start to finish. We can also remove one element for some given cost. or return the minimum cost to buy exactly one of every number from 0 to n-1 inclusive, or return -1 if it's not possible. And you can see that n and s are huge. Like you can have 100,000 sets, and you want to buy 100,000 elements, which is huge. Okay. We can try to think in a similar way, like what is the cheapest way to buy every prefix? And it is reasonable description of our state, like we don't need any more variables. We just want to find what is the cheapest way to buy every prefix. And what is not clear in this problem is actually what are our transitions. Like, suppose that you want to buy every number from 0 to i+1. It is unlikely that you will be able to do it like this, right? So it's that S contains a set which consists of one element, and you can just add it. It is also very unlikely that you will have a set like this. So basically you have some set that starts exactly here, like exactly at the first number that you are missing. And that's unlikely. At least like you may get lucky at some positions, but definitely not for every I, okay? So what is more likely is that you will have some I minus, I don't know, I minus 17 and then I plus 5. And therefore you will have to remove I minus 17 I, right? That's not really nice, because, well, you may have multiple such items, multiple sets that you can add. That, I don't know, let's say that they also produce like different final elements. So you can have multiple sets that you can buy that overlap with our current position, and therefore it's not obvious like which one do you want. Because if the lengths are like this, like here you buy more numbers to the right, and then you also buy more numbers to the left, which you will have to delete later. And like, okay, this is actually like a range sum of removals. We can consider that this is of 1, right? It's not hard to compute the cost. What is hard is to find the best. Like, which option out of this 4 is the best? Or potentially there are not 4, but like all sets have some value in common. Or maybe not all, but still, like it's not bounded by anything apart from lengths of sets. So you actually like, this is not the nice way of writing our transitions. What is a nice way is the following. Instead of adding some numbers and then removing some numbers, we can first remove numbers and then add numbers. And this is super cool. And you will see why in a minute, because in a second actually. Like instead of looking at this like this, at this interval like this, we can say like we actually remove every element from I to I minus 19. And here you remove every element from I to I minus 17. here you move every element from I to I minus 13. Here, yeah, you got the idea. Why this is cool? Because we should not really look at them like intervals. We should look at them like transitions. We transition from one prefix to the other one, to another one. You see? So this basically results in like we have different prefixes, but we also can go backwards. And you may try to find any structure in this kind of thing, but I believe that there is none. And you should just look at this like the shortest path problem. Or shortest path shortest path problem. But you may say like, hey, we don't have these edges exactly. That's true. Like what actually happens here is that we first go from I to I minus 1, then we go to I minus 2, then we go to I minus 18, and then we go to I minus 19. So for every interval that we add, we have like a long edge. But for every element that we remove, we have a short backward edge. And that's basically what's happening here. I believe I will start implementing it and then wait for some questions and scan chat for some questions. So yeah, we'll need shortest path, which is Dijkstra. And because we code in Python, I am very lazy. We will just copy the implementation of Dijkstra from PyRival, which is a super dope library for competitive programming in Python. Yeah, but I believe that you know Dijkstra algorithm. You just have like a priority queue of vertices with smallest costs, smallest distance to them, and then you do your thing. We can also save a bit in time if we remove the parent. Because we are not interested in parents, I believe. We only want minimum cost. Okay, yes. Let's say n plus 1. Because what we are going to do is for start and cost in sets, g of start minus 1. Now probably of start, we should append, actually what is the, so first we pass the vertex, which is n plus 1, I believe. And then we pass cost. Because like this is the first missing number, okay? Therefore, index cost in removals, in enumerate removals. I want to say that j of index, we want to append index minus 1 or no, not like this, because the first missing is index plus 1 here, and here we append cost. Once we do this, we want to return the Dijkstra G0 n. No, G of 0 and then n. Yeah, we got accepted for sample. I believe I can remove this explanation and submit. Okay, yeah, sometimes it's not possible. So we just have to return -1 otherwise. Yeah, and then just like this, we solved all problems about prefix sums, although I have no idea how this is related to prefix sums. Fascinating. Maybe we'll find out in the editorials. No, it's like graph. Your first approach is graph. Yeah, it looks very reasonable. I don't know. But that's okay. This is very similar. I don't know. Line sweeping. I guess you can also do this, but why would you do this if? Oh, sorry. I forgot. I forgot to turn off the sound here. Oh, somebody said, okay. Yeah, one person said it's it's very boring here because the problems are too difficult. I guess it's so when you only have 4 questions remaining. And oh, hi Pachula. I'm not sure if they are watching the stream, and probably not. So sad. Yeah, and we are not fast at all. Okay, that's still fine. Like, we spend an hour to solve 2 harder questions. I think it's already a good result, but we will keep going. Also, we have C03 here who already solved these problems. Obviously. Okay. What should we solve next? Can anyone decide for me in chat? Because I don't know. Like, I believe that this is DP and then this is DP. I believe this one. Okay, like, the problem is that this DP has 4 parameters and this DP has a inconvenient corner case, I believe. That's what I remember from like my previous encounters with these problems. I will just ask here because stream has some delay. Q4, Immortal said Q4. Oh, oof. Yes, Q4 is digit DP. I know that and I don't like that fact. I don't really know. I think we'll just solve like this one faster and then we'll come back to Q4. Is it fine? I have a technical difficulty of only having one mouse per 2 laptops. And yeah, like one of them actually has a reasonable touchpad, but it's far away, and the other one, the touchpad is just terrible. Okay, so you really want me to solve Q4? Yeah, our plan to solve everything in 90 minutes is getting less and less likely to happen. What's going on actually here? Oh. There is... No, but then it's like... probably here we can just do this in place. But then we have to loop our days in reverse order. Yeah, I think this is how you get like very fast results. Because you only have 2 rows of DP at the same time and you can fill them in place. But I believe that here you just will need to loop in reverse order, not to try one assignment twice. Yeah. Okay, so you really want me to solve Q4, okay. So here we have, yeah, C++, okay, whatever. C03 says that Q4 is evil and I should solve it last. I agree. How about solve strings down under first? So here we have a reference string s of lowercase letters and integer k. We want to count the number of strings of the same size as s, which are lexicographically smaller than s, and have at most k consecutive equal characters. Now I also want to mod the result, which is not particularly difficult. We will do it at the end. Now comes the difficulties. Like when I see the constraint like have at most k consecutive equal characters, I immediately understand that I need to know how many characters equal we have at the end of the current string. So that's one parameter. Second parameter is obviously what is the current last character. So yeah, let's just... I hope it passes time limit if I do it like this. So I is index like position in the reference string or length of our string. And we have last character. And we have count last. And what do we have? Oh, and I believe that the last parameter that we'll need is like whether our strings are already smaller than s or equal. Because if it's equal, then we have constraints of being at most s lexicographically, and if it's already smaller, then we don't care. Originally, it's true. Let's say if index is n, then we want to return 1, I believe. There is exactly one string. One way to continue, rather, like do nothing. Otherwise, we can append any character with several exceptions. Like in, I don't know, how do I write it in Python? ASCII lowercase? I believe so. No, I like... we'll have some condition here, and we'll return race. And here we'll have like race plus equals dp of some new variables. if character, let's think. If character is not equal to last, right? Our index will get greater by 1. Here I believe we want 0, then like some sentinel character, then 0, then true. So index increases by 1, last becomes new character, count last becomes 1, and here we have to think actually what to pass for equal. And you also want to think like, can I put this character? Like if it's not last, then you think like, okay, probably I can because count last is does not increase, right? Also, I will just add one simple case, if not k, then return 0. Although it's debatable what we should return if length of n is 0 and k is also 0. But I believe these guys usually return 0. I believe that in Python it's actually like if you only have additions, then the fastest thing you should do is you just should mod once at the end, because it does not really work well. Like in C++ you should mod, I believe, every time, but here you can mod at the end. Even if it overflows in 64T, it will be still faster. Or if character is different, this is not this is necessary, or is it? No, okay. Else, if character is equal to last, ways, what do we get? Index increases by 1, last stays the same, then count last increases by 1. And we also have to think what do we answer here. I don't want to think about this, so I will say like if count last is greater than k, return 0. I think it's reasonable. Yeah, sorry for that. I should really format it. Okay. So like I don't want to check here. If it's too much, I will just check in the recursive call. It's a bit slower, but it prevents code duplication, I believe. And here you have to think whether the after you append character, does the string that you are building stays the same as s, so stays equal, or it gets smaller than equal, or it actually gets bigger. So if character is actually, like if you look here and here, this becomes obvious that you can do it like this. So, one, if character is not equal to last, else count plus 1. Just to save us some if-elses, we can do it like this. Now the question becomes, like we have to be at most, lexicographically at most s. So if character is, if not equal, or character is less than s at index, I believe, then we can do it like this, because our string is either already less than s strictly, or we just made it less. Else, so if we go to else, then we are currently equal, and the only case we are at least s index. So else, if character is equal to this, then we stay equal, right? Else, we should actually stop, I believe. Like well, we can just do nothing, or we can stop. Let's test it something like this. That's not particularly smart string. Let's say abba, and then 3. Very likely that it will work, but it may TLE. No, it doesn't TLE, so probably like this it will be faster a bit. Yeah, but it's just like tiny fraction of a second. This is the most reasonable solution, I believe. So sometimes in life you just have to smash a lot of parameters into your DP and it will work. But there is not much I can do here. We can actually test one more thing, like always. What? And here we can return like this, but I believe it's actually slower. Yeah, it's like a lot slower, so in Python. Actually in C++, I guess, as well. Like as long as it does not overflow in 64T, so it's faster to take modulo once. Even like stuff like if Waze is at least mod, Waze subtract mod, I believe it works slower than just do modular operation once. At the end, because here you have a conditional statement, and for it to work efficiently you really need something like your branch prediction to guess all the time, and in some random DP which it's based on combinatorics, so you can't really tell whether we should do it or we should not after we added some random value. It's like really random. So branch prediction doesn't help you here, and because of that, it's faster to just make one slow operation at the end than to try one if else all the time and fail in branch prediction. Yes, we only have one more problem left. Do you have any questions for this one? I believe with reasonable variable names, it should not be complicated for you guys to get the idea, because you guys are smart, often smarter than me, particular Pecholia. Grandmaster in code forces, ladies and gentlemen. I'm only a master, so like, they are coloring me. Okay, so no questions about this one? Okay, explain again. Cool. Finally somebody. Yeah, and don't be surprised if I repeat the same question twice, because there is obviously some latency in stream. So if you answer in YouTube chat, then I will only get your answers in like 20 seconds, I believe. So yeah, I may repeat some questions twice. But if you type in binary search, like room chat, then I will get it straight away. Okay, so we count ways with dynamic programming, but like implicit dynamic programming. We have a lot of parameters. So first parameter is index, is how long is our current string. We're trying to build a string that satisfies the conditions, and we count the number of ways that we can build the string. So index is how many characters we already created. If we already created enough, then we have one way. It's already one valid string. One. But we also have a lot of parameters. So last is whatever is the last character of our current string. And count last is how many characters, like last, how many of that character are at the end. So for example, for ABB, last is B and count last is 2, because there are 2 B's at the end. And finally, equal is a Boolean parameter which says basically whether our current string that we are building is equal to the corresponding prefix of S. And like it's purely technical parameter, we only need it to like distinguish strictly last case or equal case. So what do we do next? We loop over all characters in alphabet that we can add them. If our string is not equal, so it's already smaller, then we can append any character. Because if string is already lexicographically smaller than prefix of S, then it will stay lexicographically smaller forever. Also, we can append a character if it's smaller than current position in S. Both of these things will lead to equal being false, so we are already strictly smaller. Then index increases by 1 because we added one character, last character becomes whatever we added, and then count last, if character that we added is not equal to last, then it becomes 1. Otherwise, it's the count. If we added the same characters, then we should increase the count of last by 1. And notice that I don't check if it exceeds k, because I check here. So the idea was to check only once in code. So we may get 2 calls, which will both return 0 because that condition got wrong, because we incremented count last. I also believe that we don't need this, actually. Or do we? It's taken a long time to execute. What's going on? Wait, no, okay, it was just their serving getting, I don't know, is everything fine? Yeah, like it looks like everything is fine with the stream. Okay. I saw that my connection got worse or anything, but no, it was just some server side issues. So if we this ternary operator, like in Python you can write it like this, and C++ I believe you can write it like character not equal to less than 1, otherwise count plus 1. So like if character is different, then there's only one such character at the end because it's new. Otherwise, we had count last of them and we added 1. Otherwise, if our string is equal and character is equal to the current position, then we go to true. Notice that it's impossible to have character greater than s at index, because if our string becomes greater than reference string at some point lexicographically, then it will always be greater than our reference string, but we want to count smaller or equal to s. So that's, we can actually break here, and it speeds things up a bit, but not much. No, actually, I don't know, like on binarysearch.com, like displayed execution time is a bit random. It depends on a lot of things, but they do measure your execution time of your program pretty accurately. Thing is that this time is they try to measure only calls to solution.solve, which is different from the execution time of the entire program. So like they try to display time which is independent of, I don't know, input-output operations. So this measurement, the displayed measurement, is pretty unstable. Hello, RIP. Oh, Oh, it does this. Okay. Yeah, but YouTube will see you only in like 20 seconds. Because we have stream latency. I'm actually surprised that Petulia did not solve Q2 yet. Oh, because in C++ you need a lot. Yeah, 4-dimensional. I believe this is like 4-dimensional DP, no? Or maybe there's some very smart solutions that I don't know, but it looks like there's not. Okay, so I guess that answered the question of Shivansh Dubey. Sorry if I pronounced it wrong. I'm terrible at pronouncing not Ukrainian surnames. Oh, and for some reason it shows 0 problems. I don't know why. We can refresh. Yeah, it shows 3 problems, and we also got Trailhead achievement. Cool. Yes, so I believe that answered the question. And we only have Q4 to solve. Am I competing against other people? No. It's like a friendly room. Oh, I did not click on editorials. Oh. Right. Because once you are smaller, then you can add whatever you want. So actually here, yeah, what if like if not equal? No. I know exactly what is his solution. His solution is 26, then n minus index, and then mod. Does it work on like state samples? No, it doesn't. Why? Why is that? Oh, okay, because you cannot have equal characters. Yeah. Yeah, you need to count like how many ways there are if you don't need that lexicographically smaller or equal to s. Like it will be a different function, but it will still be you can still compute it in linear time. Yeah, that's very true. So you can actually simplify it a lot, but then like it becomes quite complicated to read. So there is a reasonable trade-off. Okay. Yeah, and here we have 4-dimensional DP, which is like index. I don't really know what that does. Oh, that probably count last, then it's last. And then it's flag. Yeah, that's basically our solution. A bit overcomplicated, but very similar. Oh, I guess like this parameter actually means how many they have until they ran out of possible options or something like this. Whatever, like, yeah, it's still a reasonable solution. We should also put something in Java. Oh, that's good. Looks good. And yeah, apparently we can rule out some of the parameters out of our matrix. And I was just very lazy, like with this flag. But yeah, okay. Good to know that there are simpler solutions. Like, because once you are smaller, you don't really care about whether character is smaller or greater than asset index, and you can just count them like whether they are equal or not equal to last, and it becomes simpler DP. like, I don't know, 2 parameter DP. And you can calculate it faster, but we won't do it because we are running out of time actually. Yeah, we only have 5. No, okay. Like, I want to end the stream before we solve Q4. Although that's a very dangerous thing to say, because C03 said that it's evil and we should solve it last. Oof, oof. Oh, everyone's here. Oh, everyone's here. That's interesting. Did you see it? Look, look. When I switch to the next page, the indices are wrong. That's a bug report here. Okay. Oof. So here we have an equation like 1 + 2 = 5, which is obviously wrong. And we want to insert several digits into this equation to make it true. Yeah, I believe it. I remember it's digit DP, but then it was like terrible. Once upon a time, we tried to solve it with H-bar, I believe, a guy from Hungary. And it went terribly, like we couldn't figure out that's corner case that it has. Yeah. Cool, cool. So first thing we should do is split by equality symbol, and then we should split it by addition symbol, just to make sure. Let's check that we split correctly. Oh, because we could not. Okay, yes. How about then I do it like this? No, I should just say, yeah, okay, whatever. Or do we need to convert them? I think we don't, because it's like digits. Why? Okay, yeah, because we need to split xy. Yeah, I remember that contests were like 90 minutes, I guess. And it is just terrible. This question is like very hard. Because you have to figure out all the details. Oof. Okay. I am not, no, probably it will help. Okay, a cool trick, but do we need it here? Like, we only have one equality symbol, so very good. Okay, I didn't get it. Sorry. We need positions in all the strings because we'll try to insert characters at the back that will make numbers equal modulo 10. Like, if you want to make, I don't know, 4 plus 51 equals 73, and first thing you have to fix, let's write it like this. first thing that you want to fix is the last digit, because 4 plus 1 is not 3. So you have several options. One of them is to insert 9 here, because 4 plus 9 is 13. And at least they are equal modulo 10. And the second option is that you insert 2 here, because 2 plus 1 is equal to 3. Like, no matter what you do, at some point you will have to make the last digits agree, right? So you can as well make it at the very beginning. Then, like, we will have a lot of terrible time trying to fix this thing. And what I was thinking about, like, I, j, and k should be positions in x, y, and z. We discarded some suffix, and then we are working on the prefix. But I'm not, oh, that will be terrible. That will be terrible. Like, there are a lot of details here to figure out. No, it's like relatively early here, so no, I believe we will solve it before I go to sleep, but still a long time to go, a long way to go. Crow, is this correct? Let's see. Lol, okay. Yeah, so we will... guys, if you don't, unless you have like a spare hour, I believe that it's better to leave now, because there is no going back. Like, once you start watching it, so yeah. No, because there are corner cases. Like, if you just have these two cases, then you're, bro, that's easy. And then you can have such things when you, I don't know, you're trying to add 3 to 123 and get, I don't know, 678, right? And then you say, like, okay. Or probably like 3 plus 12 equals 678, right? You say, like, okay, I have a 3, so let me add 5 here. And I don't know, maybe we want to get this. Yeah, okay. So I say, okay, I add 5, then I already have 2. So let me just add 3 here, 5. So that 5 plus 1 equals 6, right? No, I'm good. But no. Like, we actually have to insert 0 here, and it's terrible. Like, because you're, yeah, it's just terrible. You have to account for that somehow. Yeah. That is super disappointing. What do we do, guys? No, the idea is basically like this. I'm just a bit afraid that if I start solving it, then like nobody will get a better understanding of that problem, because the idea is simple. You want to, like digit by digit, you want to make last digits satisfy the condition. Yeah. You see, like the educational value of this stream is quickly going down. So I believe that the most reasonable thing to do here is that we are not going to solve this problem live, because you won't actually get any value from me like trying to figure out 100 edge cases. Does it make sense? Because if it does, then we can, like, I will try to solve it, but off screen, because yeah, I don't really see how that, like me trying to figure out all the edge cases can help you guys. Like previous three problems, yes, there is something to learn. Like here, super cool Dijkstra trick, converting a problem that has nothing to do with graphs into shortest path. Here there is DP with lots of parameters, but also like a very simple way to write it. And here it's super smart sort plus DP. That sorting is nice idea. Often to get some nice substructure in your structure in your subproblems, you want to sort the array in some way. And here it was this way. So like educational value of these first three problems is quite high, but then this will be just very annoying and will take a lot of time, and I don't exactly want to spend your time, guys. So what do you think? Can we get some opinions in binarysearch.com chat about whether like I will try to solve it here, but it will be off screen. Does it work for you guys? Oh, you want a video editorial for this one. Video editorial for this one. Let me think actually. I believe that, like, because it was in some of the weekly contests, but not like first one, I believe that Alex already went over it. Like Alex Weiss already solved this problem, or at least he showed it in some of his like interviews weekly live show. So if you want to get like video editorial immediately, then you can just check his video. I don't really know. I believe he has like 46 episodes already, and there were only 56 contests, and it was not in first 10 contests, so probably it is somewhere on his channel. So if you want an immediate video editorial, then you can just watch him. I believe that his solution will be not worse than mine, probably better. Yeah, I just wanted, like, I wanted to speak about some simple logic, but I don't really want to speak about implementation of the problem. Sorry. Yeah, so like Immortal confirmed that Alex has this one as video editorial, so we can just say thanks everyone for watching, and I wanted to say like see you next time around, but we won't actually see each other on like on live streams about binarysearch.com because I will run out of problems, right? This is like legit the only problem that I have remaining, and then I'm done. That's it. One problem and that's it. So yeah, I believe I missed some Code Forces contests, so probably. It's been a long day without my friends. What is this one actually? I don't know. Is it some song? Oh, okay. Oh, but I should not have done it. Bro. I hope we don't get banned for this. I don't know how it works. Dance upon so. Yeah, I think it's fine. No, we should stop it right here. I believe I can edit it in like editor before. Okay. From the Fast and Furious soundtrack. Oh, you mean I can play the same song, but it will be like a soundtrack, so it won't. It is not like copyrighted if it's soundtrack version? How does it work? I'm not sure, I probably just won't do it. Also, for some reason I don't have my mic connected here. Okay, now I do. Bro, so yeah, I think we will do like a lot of coding to get this part to work. Has not seen Fast and Furious? No, I haven't seen it. Sorry, guys. Jamie. Oh, like if you want to listen to some music, then like in binarysearch.com there is a voice chat, right? So you can just join the room and there will be some music for you guys. So yeah, thanks everyone for watching. I hope it gave you some idea of what harder questions are like. So our solutions don't actually look big, but they are somewhat involved. Now you won't ruin my stream because like I already changed audio output to my microphone, so like to this little guy over here. So I can hear the music, but nobody else can, like not the viewers. Yeah. Yeah, that was very smart of me to change. Okay, guys, if you want to have some fun, just join binarysearch.com and we will end the stream here again. Thanks everyone for watching. I will probably have one more stream about Code Forces rounds, which I missed soon. But soon it's like, I don't know when. Probably not tomorrow, maybe actually after the weekends. And on weekends we have lead